As always, good morning, good afternoon, good evening, and hopefully good night. So we have looked at introduction to the integration, just using the rules. We looked at the basics of calculating areas enclosed between curves. And so I'm just going to go for one here. It's a little bit different. But the reason I'm showing you is because you need to know how to deal with it. So this one here, we have two functions, y equals 4x plus 16, which is a straight line, and y equals 2x squared plus 10. So here, the question is to calculate the area enclosed between the both of them. But this time, it's from x equals -1 to x equals 3, then again from 3, because that's where the curve and the line meet again, up to from x equals 3 to x equals 5. So this one, we're going to have to treat this a little bit differently. As it's saying here, there appears to be two distinct areas. So we can't just launch in with the normal rule. It would be fine. But so all we're going to do is calculate two of them separately. So a little bit of notation here. Area 1, A1, and it's going to be this part here, shaded in green or whatever colour that appears to you. And secondly, going from x equals 3 to x equals 5, I'll be declaring that as area 2. Okay. So that's fine. And just remember, in general, when you're calculating an area, it'll be a positive value. So that's what we want to end up with. I know sometimes you get notes and they just say if you get a negative value, you just change the sign at the end and everything will be fine and dandy. Maybe sometimes if you're aware of that, and it's okay, but we're going to have positive answers for both. And in order to get the total area, hopefully you can see that we'll just take the two of them and add them together. Okay, let's go for it. Our first area, which I'm calling A1, so we need to look at we need 4 pieces of information here. So the top boundary for the area is a line 4x plus 16, and the lower boundary is what looks like a quadratic parabola, 2x squared plus 10. Also, we need the extreme values of x left and right of the enclosed area, so they are x equals -1 and x equals 3. You're actually being given this information here, so there's no need to equate the curves. 2x squared plus 10 equals 4x plus 16. You could do that, and when you solved it, you would come up with x equals -1 to x equals 3. Taking a little shortcut here for you. Right, okay. So since we know the top boundary, bottom boundary, and we have the limits, we can set it up with the integral from -1 to 3, top minus bottom. And so that's what we've got there. Let's dismiss the brackets, and remember the second bracket, it's got a negative to the left of it, which means when you get rid of the bracket, you're technically multiplying by -1. That's why both the terms in the second bracket to the right will change signs. That's what's happening. The first bracket to the left will be fine. So we no longer need the graph because we know what we're doing. Okay, so we've now got 4 terms, and if any terms are similar, we can group them together. 4x doesn't have any friends. -2x squares, it doesn't have any friends either, but 16 and -10, we can group those, okay, because they're in the same family. That's what I've done there. So now I'm looking at my formula sheet and see what do they look like. Well, kind of in the family of ax to the n. So we'll just go through and integrate these one by one. We've got 3 of them. Okay, so with the 4x, that's really 4x to the 1, so that's why it went up to 4x to the 2, divided by the new power. Numbers on their own, 6. Just stick the variable on x. And the third one, x to the 2 goes up to 3, divided by the new power. Okay, and we're scanning here. I've moved the limits to the right hand side. No reason for that whatsoever, as long as we can clearly see them, because we're going to be using them in a moment. So the one thing I can simplify is a 4 over 2 in front of the x squared, so that should give me 2x squared there. Right, so that's the only change. So we've integrated. So now we're going to take this and we're going to use it on 2 occasions with the upper and lower limit of 3 and -1. So I'll just take that, copy it, okay, there and there, and remember you're all subtracting between them. Okay, our upper limit is going to go in the left hand kind of larger bracket, so we're going to put in 3 everywhere there. And getting ahead of myself there, the right hand one, it was -1. So we've inserted everything here. Lots of brackets here, lots of powers, lots of multiplication. Take your time. So 2 times 3 squared, 2 times 9 is 18, 6 times 3 is 18, 2 times 3 cubed is 2 times 27, 54 over 3 is -18. Second one, 2 times -1 squared is only 2, 6 times -1 is going to be -6. And the last term, it's going to end up positive 2/3 probably. There you go. I let your calculator do the hard work. Okay, let's sort out the contents of the left and right brackets. Left hand one looks like it's going to come down to 18 positive, and the right hand one, -4 plus 2/3, that's going to be a negative. What's that? -3 1/3 or -10/3. There you go. Okay. Please use your calculator for that. Don't decimalize anything here because you'd need to round with the 10 over 3. And it is negative as well. So just trust your calculator for the next part. Okay. So your calculator might throw out 64 over 3, or it might throw out 21 1/3, or you might go for the decimal option. It just depends what you need the answer for. Do you have a story? We don't. Here, we're talking about areas. I should have really put in units squared, but I'm going to leave that till the end. I'm just interested in the numbers here because I've only worked out one area here. What I noticed about all the answers or the versions of the answer is they are positive, because as I said earlier, our areas in general will be positive. Okay, That's us dealt with area 1. Let's move on. So I've just chopped up the initial image and I'm only looking at area 2. And so we're interested in how this is bounded in terms of the curves and in terms of the x values and limits. So here, the top boundary this time is a parabola, y equals 2x squared plus 10, and the lower bound of boundary is 4x plus 16. Right, that's okay. So we just need the other two, and they are the limits, the x values, extreme left value, extreme right value. So x is 3 to x equals 5. So we've got our 4 components here that we need. So here we go. So it's going to be the integral from 3 to 5 of top minus bottom. And we'll just put in the functions without the y. So there we go. Put them in. I always like to use the brackets here for the top minus bottom part. The left hand one, the 2x squared plus 10, when I get rid of the bracket, it'll stay the same. But when I get rid of the right hand one, you're technically multiplying everything by -1. So we'll end up with a -4x and a -16 there. So there you go. As per the first one, we'll look and see if we can gather any like terms. So the 2x squared that's on its own. Over got a positive 10, we're taking away 16, so it'll go to -6. And a -4x, it'll stay on its own. Put them in any order you want. Okay, we've got 3 terms here. They're all of the form ax to the n, although some of them are special cases, but you know how to deal with these. So let's just go and integrate. I've just taken this to a new page, so everybody's aware. Nothing's changed here, just to give me a bit of space. Let's integrate them. So 2x, that will go to 2x to the 3 over 3. -6 will go to -6x, and -4x will go to -4x to the 2 over 2, which we can simplify. I've just did that in one go because it's very, very similar to the previous one, because the two boundaries are actually still the same, except I've changed places. That's all that's happened here, so it's going to look very similar. It's just the signs are going to change for this one. Just remember, we've got the limits 5 and 3. So now we're going to take those, we're going to copy and paste whatever's in the rectangular bracket, copy and paste it. There you go, there's 1. I've only got rid of x. There it is again. And remember, you're always subtracting between these two. Okay, the upper limit is 5. It'll go in the one on the left. And the lower limit of 3, it'll go in the one on the right. So you just take your time with your calculator. The one on the left, 2 times 5 cubed, that's 2 times 125, that's 250 over 3. Take away 30, take away 2 times 5 squared, that's you'll be taking away 50 there. Second one, 2 times 3 cubed, that's 2 times 27, 54 over 3, 18. Take away 18 and take away another 18. So this is looking very similar to the first one. Just looks like things have maybe changed place. With the second bracket anyway, that appears, well, it should appear the same because it was 3 we inserted. But the first bracket, okay, it looks a little bit different, the one on the left. We've got 250 over 3, that's not nice. So we'll just type it into the calculator here, and we'll do the same in the second bracket. Okay, 10 over 3, we're taking away a negative, so you can think of that as negative, negatives gives a positive, so 10 over 3 add 18, put that in your calculator. If you wanted a common denominator, that would be 10 over 3 plus 54 over 3 to give you 64 over 3. Trust your calculator. There you go. So, 64 over 3, that answer's fine. Sometimes your calculator can change it to a whole number plus a fractional part, 21 over 3. Or, if you're in the decimal gang, you might want to put it as 21.33, whatever, and round it according to your needs. I know it's an area, I know the units should be squared, as with area 1, I'm going to leave area 2 without the unit squared until the end. If you feel the need to put them in midway during the process, that's fine. But as long as they appear in the eventual answer, I'm happy with that. And hopefully you're happy with that. Right, here we go. Calculated both of them. A1 was 64 over 3, A2 was 64 over 3, because whoever thought of this question, they constructed it quite well. It's not always the case. But both answers are positive, that's fine. But remember, it's a total area we want, so it's a combined area. So the combined area, so A with a subscript T, total area is just both of them added together, so A1 plus A2. So just take those two values, 64 over 3 plus 64 over 3. Let's just add them as fractions, so 128 over 3, hopefully. Yep, that answer's fine. As I've stated previously, we don't have any context, it's just an area. Leave it as a fraction there, 128 over 3. Or you could write it as 42 and 2/3 over 3. Or if you want to decimalize it for whatever reason, there you go, 42.66. I've actually rounded it there. The third one up to 7. That's fine. But you know it's 0.6666 recurring forever. Okay. Since it is, we've now got the total area. They haven't given us any specific units, dimensions, centimeters, millimeters, meters, inches, anything like that. Yeah, so I'm just going to put down units squared at the end. And I'm going to leave it there, folks. So hopefully that was short and sweet. But please concentrate on this one. Because we had two distinct areas. And it was really important when we were setting up the question, when looking at each of them, we had to know which one was the top boundary, which one was the bottom boundary, and they gave us the limits here. So we were quite lucky. So that this was a time-saving question by giving you the limits. So I'm going to finish this one here. So let's see, I think that was quite quick. There you go, 19 and a bit minutes, maybe 20 minutes. Time I hit the pause button. So that was quite good. So just as you know, you can pause this all the time. So I'm going to close it there, folks. 20 minutes. Right. Bye for now. Bye bye.